Assalamualaikum and hello. This is my presentation for my final project titled Comparison Study on the Antioxidant Capacity of C. odorata leaf extract obtained from maceration and ultrasound-assisted maceration. The first is the abstract. Antioxidant can be extracted from plants, hence the study aimed to extract antioxidants by making use of two different extractions and study the effect on yield and antioxidant capacity. This is because the two extraction method application approach is rarely seen in extraction research. From the study, it is found that ultrasonication improved maceration technique yield by approximately 50%, as well as the antioxidant capacity of extract. Longer extraction time also increases yield and antioxidant capacity of extract. The order antioxidant capacity of both assays are the same, with the lowest is maceration at 48 hours, and then maceration at 120 hours, followed by ultrasound-assisted maceration at 48 hours, and finally, the largest yield is obtained by ultrasound-assisted maceration at 120 hours. Hence, the application of ultrasonic-assisted extraction with other extraction techniques should be approached, as it improves the efficiency of extraction process and the extract quality. Now we proceed with introduction. ODORATA L have been categorized as one of the highly serviceable plants in medicinal field because of its significant antioxidant properties that can greatly enhance the wound healing process. The excellent oxidation capacity of C. odorata is mainly contributed by its high content of bioactive compound called antioxidants. Antioxidants can be obtained from plants through various extraction processes. However, the study to determine the optimal method for the highest antioxidant activity per extract yield have not been much pursued in the research scene, especially the extraction method that make use of two different extraction techniques. Therefore, this study aims to explore the effectiveness of applying two different extraction techniques, which is ultrasound-assisted extraction and maceration extraction, on the extraction yield and antioxidant capacity. And then we proceed with the methodology. So first, we obtain the sample of Commolena odorata from by planting sapling and wait for 8 weeks. So we use an 8 weeks old Commolena odorata leaf sample, which is then prepared by drying in a drying oven and then grinded using rotary evaporator. Then the sample will undergo extraction, which is maceration extraction and ultrasound-assisted maceration at two different extraction time, which is 48 hours and 120 hours. The result from this is 4 extract, and the weight or dry weight of the 4 extract is calculated the yield. So for the second objective is the antioxidant assay, where the 4 extract is used for antioxidant evaluation. The first is the DPH assay and then the FRAP assay. So from this we know the antioxidant activities for each extract and we can make comparison. Also the comparison is made with the standard use. The DPH is comparison with ascorbic acid and FRAP is comparison with gallic acid. So, and finally is for the quantification of antioxidant in extract. So for the quantification of antioxidant, we identify two, which is gallic acid and ascorbic acid. So from there we know the concentration of gallic acid and ascorbic acid in the extract. So, and then we proceed with the result. First is the extract yield from C. odorata. So, we can see here that the highest amount of yield obtained is by the ultrasonic-assisted maceration at 120 hours extraction time, which is at 87.36%. And the lowest is by maceration at 48 hours, which is 13.26%. And then the antioxidant assay. So for the antioxidant assay, higher absorbance signifies stronger antioxidant capacity. So from here, the absorbance reading of standard gallic acid is lower than all of the extract, meaning that the antioxidant capacity of gallic acid is stronger than the extract at 1 microgram per milliliter concentration. So among the extract, C. odorata extract, The highest antioxidant capacity can be seen by the ultrasonic-assisted maceration, and the lowest is by maceration at 48 hours. And then for the DPPH, which is by ascorbic acid, so also can be seen here that the ascorbic acid absorbance is lower, meaning that the ascorbic acid has higher antioxidant capacity at concentration 1 microgram per milliliter. And same with the DPPH, the ultrasonic assisted maceration at 128 hours obtain have the highest antioxidant capacity because lower absorbance reading, and maceration at 48 hours have the highest absorbance reading, so it has the lowest antioxidant capacity among the extract. Finally, for the result for quantification of gallic acid and ascorbic acid, so it is noted that there is a noteworthy amount of ascorbic acid and gallic acid in the all for extract. So the content of this gallic acid and ascorbic acid approximately 1/5 of the extract concentration. So the order for the gallic acid ascorbic acid was determined by the same. It's determined to be the same, which is maceration 48 hours with the lowest amount of gallic acid and ascorbic acid, followed by maceration at 120 hours, and then ultrasound assisted maceration at 48 hours, and finally, with the largest content of ascorbic acid and gallic acid is ultrasound assisted maceration at 120 hours. So conclusion, overall, this study found that ultrasonic assisted maceration and longer extraction time has a significant advantage in maximizing the rate of C odorata extraction. The largest extraction yield was obtained from ultrasonic assisted maceration at 120 hours of extraction time. Additionally, the extract from ultrasound assisted maceration also has a significantly higher level of antioxidant, especially at 120 hours extraction time. Concentration of ascorbic acid and gallic acid were discovered contained in all C odorata extract with higher concentration using ultrasonic assisted maceration at 120 hours of extraction time. And so, this is the reference that I use to make that is used for my studies. And that is all. Thank you for listening to my presentation.